Have you ever wondered how temperature is controlled in various devices? Ever felt curious about the magic behind your air conditioner or refrigerator maintaining a constant temperature? This marvel of engineering, often overlooked, is the result of an ingenious device known as a temperature controller. It's the unsung hero working tirelessly behind the scenes to ensure your comfort and the functionality of many devices. Today, we will unravel the mystery behind temperature controllers. Stay tuned. So, what exactly is a temperature controller? You might be surprised to know that it's a device you interact with more often than you think. At its core, a temperature controller is a device that regulates the temperature of a system using a feedback sensor or an on-off algorithm. This might sound complex, but let's break it down a bit. Imagine you're baking a cake. You set the oven to a specific temperature, and the oven's built-in temperature controller ensures that the heat stays consistent. It's constantly monitoring and adjusting, much like a diligent baker checking and rechecking the oven temperature. Temperature controllers are found in a myriad of devices, from industrial furnaces to home appliances, even in your car's air conditioning system. They play a critical role in maintaining the right temperature, ensuring optimal performance, and preventing overheating or freezing. In essence, a temperature controller is like a thermostat on steroids, capable of maintaining the temperature in a wide range of devices. Now that you know what a temperature controller is, you might be wondering, how does it work? Well, let's dive right into it. There are two main methods of temperature control: PID control and on-off control. PID control, which stands for proportional integral derivative, is a type of control that uses a complex mathematical formula to maintain a constant temperature. The PID controller continuously calculates the difference between the desired temperature and the actual temperature, then adjusts the output to minimize this difference. It's like having a very skilled driver who's constantly adjusting the steering wheel to stay on course. On the other hand, on-off control is a simpler method. It's like a basic thermostat. When the temperature drops below a set point, the controller turns the heat on. And when the temperature rises above the set point, it turns the heat off. It's a more straightforward but less precise method. Regardless of the method used, a key component in temperature control is the feedback sensor. This sensor measures the actual temperature and sends this information back to the controller. It's the controller's eyes and ears, so to speak, allowing it to know when to adjust the output to maintain the desired temperature. So through either PID control or on-off control, a temperature controller ensures that your devices maintain the desired temperature. Understanding how a temperature controller works is one thing, but how do you choose the right one for your needs? Well, the first consideration is the type of control you need. Do you need a proportional integral derivative or PID control, which offers more precise temperature regulation, or will an on-off control suffice? Next, consider the temperature range of the device. Temperature controllers aren't one-size-fits-all, so be sure to choose one that matches the temperature range your device will be operating in. Finally, consider the type of sensor required. Thermocouples and resistance temperature detectors, or RTDs, are common, but they have different strengths and weaknesses. For example, thermocouples can handle higher temperatures, while RTDs are more accurate over a smaller range. So there you have it, the type of control, the temperature range, and the sensor type. These are the key factors to consider. Remember, the right temperature controller can make all the difference in maintaining the optimal performance of your device. So there you have it, a simple explanation of what a temperature controller is and how to select the right one. This versatile device, whether it operates on a proportional integral derivative function or an on-off algorithm, plays a critical role in maintaining optimal temperatures in a multitude of settings. It's the unsung hero in our daily lives, ensuring our comfort and the proper functioning of numerous appliances and industrial processes. When choosing a temperature controller, it's essential to consider your specific needs. Whether it's for a home appliance or an industrial process, the type of sensor, the control algorithm, and the desired accuracy are all crucial factors to consider. Remember, The right temperature controller can enhance efficiency, improve product quality, and even ensure safety. So, make your choice wisely. The next time you enjoy a cold drink from your refrigerator or bask in the cool air from your air conditioner, remember the humble temperature controller working tirelessly behind the scenes.